Hello everyone, welcome. Today we'll be reviewing 25 practice problems focused on chemistry for your ATI TEAS exam. This video includes explanation of the answers. If you want to review much quicker without the explanations, I have another video with the exact same practice problems, and I'll leave the link to that video below. Also, all of these questions are based off the topics I have already reviewed and more in the complete review of chemistry video. So if you need to watch that specific video, I'll leave the link below as well. Let's go ahead and get started. Alrighty, question number 1. Which of the following best describes the relationship between these carbon isotopes? Carbon with an atomic mass of 13 and carbon with an atomic mass of 14. Okay, so our answer is D. Carbon with a mass of 14 has more neutrons than carbon with a mass of 13. So first off, isotopes are various forms of an element, and the only thing that changes in isotopes are the number of neutrons. So since the number of neutrons changes, this is actually going to reflect the atomic number, since the atomic number is the number of protons and neutrons. So let's compare carbon 13 and 14 side by side. The 13 and the 14 indicate the mass number. So carbon 13 has a mass number of 13 and carbon 14 has a mass number of 14. So remember, these are both carbon, so the number of protons will never change because it's its identification. So on both sides, we have number of protons 6. Now the number of neutrons is going to change. Remember, our mass number is the number of protons and neutrons. So simply we're going to take 13, subtract 6 protons from it, and we're left with 7 neutrons. So carbon 13 has 7 neutrons. Now, if we do the same thing for carbon 14, we're just going to take 14 minus the 6 protons, and we're left with 8 neutrons. So our carbon 14 with 8 neutrons has more neutrons than the carbon 13. Question number 2, which of the following is an acid? Select all that apply. Our answers here are C, hydrogen iodide, and D, hydrochloric acid. A hint to identifying bases and acids is that bases are likely to have OH in them or are metals attached to a hydrogen ion. Acids are likely to start with the hydrogen ion and are attached to a non-metal. So notice NaOH and KOH, these both have OH in them, so they are bases. And HI and HCl, these both start with a hydrogen ion, so they are acids. Just know that this hint doesn't always 100% work to identify acids and bases. Sometimes you need to be given some chemical characteristics or a chemical equation. The best way, I believe, to know the difference between acids and bases is just to memorize the most common acids and bases. Question number 3. Which of the following phase changes requires loss of heat? Select all that apply. Our answer here is C, deposition, D, condensation, and E, freezing. This is what we call a cooling curve, and it includes condensation, freezing, and deposition phase changes. All three of these phase changes are going to decrease in temperature as heat or energy is removed from them. Remember that during a cooling curve, the molecules are releasing energy in the form of heat, and this decreases the temperature. The decrease in temperature causes cohesion to increase. And remember, cohesion is pretty much like the glue that keeps the molecules together. So this decrease in temperature causes cohesion to increase, and the molecules come closer together. They become more compact. As a result, they gradually come closer and closer together until they have no room to move. At this point, the substance becomes a solid because remember, solids do not move. They just vibrate in a fixed place. The molecules vibrate in a fixed place. Here's a supporting image of what molecules would look like as they transition from a gas to a liquid and a liquid to a solid. Notice that in a gas, the molecules are spread apart more. Then as they go to a liquid, they come closer together, meaning cohesion increases, right? Cohesion is like that glue that glues the molecules together. And then as they go from a liquid to a solid, cohesion is increasing even more. So the molecules are coming even closer together. In a solid structure, this sort of form that you see that the molecules are all stuck together, this is known as a lattice structure. This is when the molecules are very compact in a solid and they are actually not moving. They stay in one place and they vibrate in one place. So just remember, as these molecules are going from a gas to a liquid to a solid, most important, you need to remember that they are releasing heat, and this release in heat is decreasing the temperature and increasing cohesion between them. Question number 4, which of the following phase changes requires increase of heat? Select all that apply. Our answers here are A, melting, D, sublimation, and E, vaporization. So here we have a heating curve, which is the opposite of a cooling curve. It includes the phase changes melting, vaporization, and sublimation. Here, molecules are gradually absorbing energy in the form of heat. As they absorb this heat, of course, the temperature of the substance is going to increase. This causes cohesion to decrease. When cohesion decreases, the molecules will spread out further from each other. Here's a supportive visual of what the molecules look like as they transform from a solid to a liquid to a gas. In a solid, the molecules are close together. Remember, this is a lattice structure. And as these molecules absorb more heat, they move more further apart from each other until they reach a gaseous form where they are most spread apart. And also in this phase, they have a high kinetic energy. They have a high kinetic energy because they are able to move so freely and quickly around. But on the other hand, molecules in a solid have low kinetic energy because they aren't able to move around at all. Question number 5. Which of the following elements have the same number of valence electrons as lithium and share similar chemical properties? Use the periodic table given and select all that apply. Our answer here is A, hydrogen, B, sodium, and C, potassium. Going vertically up and down the periodic table, we have what we call groups or families. They are numbered 1 to 8. The group number is equal to the number of electrons on the atom's valence shell, or in other words, the valence electrons. Lithium is in group 1. That means it has 1 valence electron, and so do all the other elements in this group. All these elements also share similar characteristics. That's why hydrogen, sodium, and potassium is our answer here. Question number 6. A neutral atom of magnesium has 2 valence electrons. Which of the following is most likely to occur when magnesium forms an ionic bond? Our answer here is A. Magnesium will lose 2 valence electrons in order to have a full valence shell. Notice that the question is saying magnesium will form an ionic bond. In an ionic bond, atoms transfer electrons. They do not share electrons. Sharing electrons is covalent bonds. So we can automatically rule out answers B and C because these both say that magnesium will share its electrons. In an ionic bond, atoms transfer electrons. Metals particularly tend to have fewer valence electrons, so it's easier for them to lose electrons when forming an ionic bond. Magnesium here has 2 valence electrons, and when it loses its valence electrons, it loses that ring as well because there are no electrons occupying it. So underneath, it has a full valence shell, or in other words, it has 8 electrons occupying its outermost shell. Question number 8. Which of the following best describes oxygen with 8 protons, 10 electrons, and 8 neutrons? Our answer here is C, oxygen as an anion with a -2 charge. An ion is an atom with an electrical charge. An atom gains a charge if the number of protons and electrons differ. In contrast, remember a neutral atom has the same number of protons and electrons. If an atom has more protons than electrons, it is a cation with a positive charge. If it has more electrons than protons, it's called an anion with a negative charge. In the question, we're given all the information we need here. 8 protons that I'll represent using a positive sign and 10 electrons that I'll represent using negative signs. We are also given the number of neutrons, however, it really has no relevance here. So don't let that trip you up. A positive and a negative always cancel each other out. So if we keep crossing out the pairs of positive and negatives, eventually we'll be left with 2 extra electrons. That makes this oxygen an anion with a -2 charge. Which number sequence best balances the chemical equation given? Our answer here is D, 1, 3, and 2. Let's first start off by writing the number of each atoms of each element. So looking at nitrogen first, this 2 subscript indicates it has 2 atoms. Hydrogen also has a subscript of 2, so hydrogen also has 2 atoms. Looking at NH3, we have a 3 subscript, and we know that this 3 is only referring to the hydrogen that it's attached to. So NH3 has 1 nitrogen and 3 hydrogen atoms. Let's take the numbers from our answers and fill in the blanks here. The coefficient numbers change everything in the amount of atoms, so let's go ahead and recalculate this. 2 times 1 is going to give us 2 nitrogen. 3 times 2 is going to give us 6 hydrogen. 2 times the 1 nitrogen is going to give us now 2 nitrogen. And 2 times the 3 hydrogen is going to give us now 6 hydrogen. Now looking at both sides of the equation, we can see that we have balanced out the amount of atoms. Nitrogen is balanced out with 2 on both sides, and hydrogen is also balanced out with 2 on both sides. So the coefficients of 1, 3, and 2 worked perfectly here. Question number 10. How many oxygen atoms are present in the reactant side of this equation? Our answer here is B, 50. So our reactant side of the equation is on the left side, and the product side would be on the right side. So when we have a coefficient in front of an element or a compound, we multiply that coefficient by any subscripts. So in this case, we multiply 25 times 2 and we get 50 oxygen. So we have 50 total oxygen on the reactant side. Although we already answered the question, I just wanted to add here that the atoms on both sides of the equation will be the same amount. So on the product side, we also expect there to be 50 oxygen atoms. So let's do a quick count here. 18 times 1 is 18. If you see no subscript number, it basically implies that there is a 1 there. So just imagine there is an imaginary 1 here. In CO2, we multiply 16 times 2 and we get 32. Add the 32 and the 18 together and we get 50 total oxygen atoms on the product side as well. Again, that wasn't part of the question. I just wanted to give you guys some extra practice if you needed it. Question number 11. The following are examples of acids: orange juice, coffee, and hydrochloric acid. What range would the pH of these substances be in? Our answer here is D, less than 7. So anything less than 7 is an acid. Anything more than 7 is a base, or it is alkalytic. 7 itself is neutral. And I just want to add that the further you go up the scale towards the pH of 14, the stronger the base is. So a solution with a pH of 14 is stronger than a solution with a pH of 10. And the further you go down towards the 0, the stronger the acid will be. For example, a solution with a pH of 1 is much stronger than an acid with a pH of 6. Also, on a side note, hydrochloric acid is such a must know for the TEAS exam. It's super high yield. Make sure you know roughly where it stands on the pH scale, right around 1, a pH of 1. Make sure you know its function and make sure you know its molecular formula so you can identify it. Question number 12. Which of the following are examples of a homogeneous mixture? Circle all that apply. Our answers here are A, milk, B, air, C, blood, E, salt water, and F, black coffee. So there are two types of mixtures, homogeneous and heterogeneous mixtures. In a homogeneous mixture, the composition is uniform throughout the sample and there are no distinct boundary lines. It's quite simple to identify once you look at some practice problems. So for example, in this milk, there is a mixture of different types of components. One of those components is the sugar, the other is water, the other is the actual milk itself. And each one of these components have a different chemical composition. So if you look at them molecularly, the molecular formula is going to be different for sugar, for water, and for the milk. In the coffee, there's water and there's coffee grounds. In the salt water, there's salt and there's water. In the blood, there is red blood cells, white blood cells, platelets, plasma. In the air, there's a mixture of oxygen, carbon dioxide, and let's just say like pollutants that it carries around with it. So these all have one major thing in common. They all have a uniform composition. In other words, you can't see the individual components. They basically all blend in together. In a heterogeneous mixture, it's basically the opposite. The composition varies. You can clearly see different components individually. It's just not well blended. So, for example, this boba drink, you can see the tapioca balls separate from the tea. In the pizza, you can see the pepperoni separate from the other ingredients like the basil and the mushroom and the cheese. If all else fails and you can't actually remember the definitions of homogeneous and heterogeneous mixture, just remember homogeneous looks like if you dumped all the ingredients into a blender and blended it up really, really well. Everything looks even and uniform. In a heterogeneous mixture, it's exactly the opposite. It looks like you haven't put anything in a blender and you can see all of its components, its ingredients separate. Question number 12. Fill in the blank with the word that best fits the description of a metal. Use the following sentence. A metal generally has a blank appearance, is a blank heat and electrical conductor, and are blank ductile. Our answer here is C, shiny, great, and highly. So if we filled in the blank here, the sentence would read out, a metal generally has a shiny appearance, is a great heat and electrical conductor, and are highly ductile. So metals, nonmetals, and metalloids, the characteristics of each is very important. You must memorize and understand the characteristics of each of these. So let's review them quickly. Metals have a shiny luster. They are great heat and electrical conductors. They are malleable and ductile, and they have a high melting and boiling point, meaning that it takes a lot of energy in the form of heat to get a metal to melt or get it to a boiling point. Nonmetals are pretty much the opposite. They are dull in appearance. They are poor heat and electrical conductors. They're not very malleable or ductile. Instead, they're brittle and they pretty much just break easily. And they have a low melting and boiling point, meaning it does not take a lot of heat energy to get them to a melting or boiling point. Metalloids have properties of both metals and nonmetals, so it really just depends on the singular metalloid element. Question number 13. Which of the following expresses a compound? Select all that apply. Our answers here are A, C, D, and H. So let's go through each of these answers one by one. And remember, a compound consists of two or more different types of atoms. Emphasis on different types of atoms. So NaCl, Na, sodium is one type of atom. Chlorine, Cl, is another type of atom. So two types of atoms together create a compound. H2, H is one type of atom. And so this is not a compound because it's only one type. H2O, we have hydrogen, that's one type of atom. Oxygen, that's another type of atom. So two types of atoms put together, this is a compound. NH3, nitrogen is one type of atom. Hydrogen is another type of atom. So we have, again, two types of atoms put together. This makes a compound. F2, F is our, fluorine is our only type of atom here. So this is not a compound. Mg, this is magnesium. Magnesium is only made of one type of atom, so this is not a compound. He, this is helium. This is only one type of atom. This is not a compound. CO2, you guessed it, carbon is one type of atom. Oxygen is another type of atom. Two types of atoms put together equals a compound. Question number 14. Which of the following will have the greatest atomic radii? Use the periodic table given. Our answer here is potassium. So luckily there is a periodic table trend that you can memorize for atomic radii. Atomic radii increases from right to left on the periodic table. So as you go more to the left, the atomic size increases. And the atomic radii also increases as you go down the periodic table. So the further down you are on the periodic table, the larger the atomic radii will be. So if we locate all of the given answers of the elements on the periodic table, we just have to find the element furthest to the left and lowest on the periodic table. That element is potassium. So potassium has the largest atomic radii. Question number 15. Which of the following will have more ionization energy? Use the periodic table given. Like our previous question, this also has a periodic table trend that you can memorize. It's actually going in the opposite direction of the atomic radii. Ionization energy instead increases from left to right on the periodic table. So the further right you are on the periodic table, the more ionization energy that element will have. Ionization energy also increases as you go up the periodic table. So the higher up you are on the periodic table, the more ionization energy a element has. So if we look for all of the elements that are given here in the answers, we locate the one that is furthest to the right and highest on the periodic table. That element is going to have the most ionization energy. So we can clearly see that helium has the most ionization energy here. Question number 16. Arrange the atoms in order of increasing electronegativity. Use the periodic table given. And remember, increasing electronegativity means you start with the atom that has the lowest electronegativity and you end with the highest electronegativity. Our answer here is potassium, sulfur, oxygen, and then fluorine. That is our correct order of increasing electronegativity. So I just want to mention, do not confuse electronegativity with ionization energy. Ionization energy was in our previous question. Also, if you aren't too familiar with the periodic trends, I have a video that just focuses on periodic trends, including atomic radii, electronegativity, and ionization energy. I just don't want to put too much detail in this video because it is a lot of information. So you can go ahead and look for that video. Okay, so electronegativity moves in the same way that ionization energy moves in. It increases from left to right on the periodic table. It also increases as you go up the periodic table. So our most electronegative element is fluorine. And so generally the electronegativity increases as you make your way towards fluorine. Noble gases do not participate in electronegativity, so don't include them. That's why fluorine is our most electronegative atom and not helium. So if we locate all of the given elements in the answer, we can see that potassium has the least electronegativity. Looking at sulfur and oxygen, it looks like either one could be next. They look both equidistant to fluorine. The rule is, as you go up the periodic table, the electronegativity increases more than if you're going right on the periodic table. So with that said, oxygen has more electronegativity than sulfur. So we can continue the order with sulfur, then oxygen, and then ending with fluorine. Question number 17. Which of the following best describes the type of chemical reaction? Our answer here is D, double displacement. In a double displacement reaction, we have two elements replacing two others. This is the generic form of a double displacement. We start with our outer two elements in both compounds, which here are A and D. We combine them in the product side to make AD. Then we take the inner two elements of both compounds and combine them in the product side to get CB. One more thing to remember is that you must end up with a pair of positive and negative atoms together. So notice that our products AD finish off as a positive and negative pair. Same with CB, they also finish off with a positive and negative pair. Looking at our given example, how do we know that this is a double replacement or double displacement? Well, it looks very similar to the generic form we just went over. The two outer elements, Ag and Cl, combine to make AgCl, and the two inners combine, NO3 and Na, to make NaNO3. Question number 18. Which of the following is not an example of a synthesis reaction? Our answer here is D. In a synthesis reaction, we are combining our elements or our compounds to make a completely new compound on the product side. So here in our first answer, we have two compounds, those being CaO and H2O, and they have combined to make CaOH on the product side. So this is an example of a synthesis reaction. Here we have sodium and chlorine that have combined to make sodium chloride. This is also a synthesis reaction. Here, NO and O2 have combined to make 2NO2. This is also an example of a synthesis reaction. Lastly, we have magnesium plus H2O yields MgO plus H2. Here there is no combining of any compound or elements. So this is not an example of a synthesis reaction. Instead, this is actually a single displacement reaction. In a single displacement, one reactant is replaced by another. This is what the generic form of a single displacement looks like. A is replacing B. I like to think of it like a dance where a single person is dancing and then you have a couple that's dancing. Then the single person comes in and switches places with one of the partners. So if we look at our answer D, we have magnesium that is taking the place of hydrogen in the compound, and then hydrogen is taking magnesium's place. So there's basically one switch between two types of atoms. Question 19, fill in the blank. Metals tend to blank electrons because blank. Our answer here is D. So if we fit this answer into the blanks of the sentence, it would read, metals tend to lose electrons because they have fewer electrons in their outer valence shell. So here we have an example of aluminum as our metal. This aluminum has 3 valence electrons. It is easier for metals to lose their electrons when forming bonds because they have a few amount of them. So aluminum is going to lose its 3 electrons, and now the shell that was once a home to them is now empty. So aluminum is actually going to lose a shell because it's unoccupied, and underneath it has another shell with 8 electrons, just what it needed, and this becomes its full valence shell. So if you're wondering why it's easier for aluminum to lose its 3 electrons instead of gaining all of them, okay, think of it like this. the aluminum wants 8 electrons to fill its valence shell, right? That's its goal, is to fill it with 8. So it has two options. Either one, it's going to lose the 3 electrons and then underneath it has a full 8, right? So it could do that. Or it can gain 5 electrons, but it's going to require way more energy for this aluminum to attract 5 electrons to fill its valence shell rather than just losing the 3 that it already has. Question number 20, fill in the blank. Nonmetals tend to blank electrons because blank. Our answer here is A. So the sentence would read, nonmetals tend to gain electrons because they have more electrons in their outer valence shell. So here we have carbon as our example of a nonmetal. Notice it has 4 valence electrons. Because it's a nonmetal, we know it will gain some electron to fill its outer shell. So here comes along an oxygen atom that would love to make a pair with this carbon atom. Oxygen atom shares a few of its valence electrons with carbon, hence carbon gaining electrons, and carbon is also going to share some of its valence electrons. Now, carbon and oxygen adjust their valence electrons so that they both have 8 electrons in their outer shell, which means they're both happy because they have a full valence shell. Question 21. Which of the following represents covalent bonds? Our answers are A, B, D, E, and F. So remember, in a covalent bond, you're going to have 2 nonmetals. So let's go through each of these answers. Here we have HO, so hydrogen and oxygen. Both of these are nonmetals, so this is a covalent bond. Again, we have H2O, so again we have H and O, so 2 nonmetals. This is a covalent bond. Here we have Na and Cl, sodium and chlorine. Sodium is actually a metal and chlorine is our nonmetal. Metal and nonmetal is a ionic bond, so this is not covalent bond. HCl, again, we have 2 nonmetals. That's a covalent bond. NH3, we have 2 nonmetals. This is also a covalent bond. PCl, phosphorus, and chlorine. These are both nonmetals, so this is a covalent bond. NaF. So again, sodium is a metal and fluorine is our nonmetal. So metal and a nonmetal is an ionic bond, not a covalent bond. Question 22. Which best describes the following compound? Use the electronegativity values given of each. Our answer here is A, polar covalent. So this is the compound we are given, and these are the electronegativity values attached to each of them. If the difference in electronegativity between the two types of atoms is 0.5 or more, then it's considered a polar covalent bond. If the difference in electronegativity is less than 0.5, then it's considered a non-polar covalent bond. So to find the electronegativity difference, we just use some subtraction. So 3.0 minus 2.5 is 0.5, and 0.5 is our electronegativity difference between carbon and chlorine. Because the electronegativity difference is 0.5, that makes this a polar covalent bond. Question number 23. How many protons and neutrons are in chlorine-36? Use the periodic table given. Our answer here is B, 17 protons and 19 neutrons. So first off, let's locate chlorine on the periodic table because we'll need that information later on. Next, let's take this chlorine-36 and move it over here so we can see it bigger and break it apart. When you see an element written out with a dash and a number after it, this is indicating that the atom is in isotope form. The number is representing the mass number. So this chlorine is in isotope form. Remember, mass number is equal to the amount of protons and neutrons. To find the number of protons, we use the periodic table, and the atomic number will tell us how many protons the chlorine has. Remember, this number will never change no matter what variation chlorine is in, because the atomic number or the number of protons is the signature of the atom. So this isotope has 17 protons. To find the neutrons, we subtract the number of protons from the mass number, so we get 19. So there's no indication that this chlorine is an ion, so we must assume it has no charge. If it has no charge, that means that the number of protons and electrons are equal to each other. So we get 17 electrons. The key here is that you're able to identify this chlorine as an isotope and use the mass number given to make your calculations. So if you didn't do this, you would probably round the atomic mass to 35 and subtract 17 to find the number of neutrons. This would give you 18 neutrons, and that would be wrong. So make sure you see the isotope, identify the isotope, and use the mass number that it gives you to make your calculations. Question number 24. Identify the Bronsted-Lowry base and conjugate acid. Our answer here is A, H2O is the Bronsted-Lowry base and H3O is the conjugated acid. The Bronsted-Lowry theory states that acids are proton donors. In other words, they lose a proton. And bases are proton acceptors. In other words, they gain protons. Remember, protons are equivalent to hydrogen ions when we talk about acids and bases. Let's look at our equation. Look closely at H2O. It turns into H3O on the product side. The difference is hydrogen has gained another hydrogen, hence the 3 and not the 2. That makes H2O our Bronston-Lary base because it accepted or gained a hydrogen ion. We can also say it gained or accepted a proton. A Bronston-Lary base will always be paired with its conjugated acid. So H3O is our conjugated acid. Question number 25. Find the average number of neutrons in a bromine atom. Use the periodic table given. Our answer here is A, 44.9. So first off, let's locate bromine on the periodic table. And remember, our atomic number is the number of protons, and our atomic mass, rounded, would be the number of protons and neutrons. So before we look at the average number of neutrons, which is what the question is asking for, I want to review how to find the number of neutrons so that you can compare the two. To find the number of neutrons, we would round the atomic mass to a whole number, giving us 80, then subtract the atomic number, 35. So we would get 40 neutrons. Now the question is asking the average number of neutrons, emphasis on average. To do this, you would not round the atomic mass. Again, don't round the atomic mass. So 79.9 minus 35 is equal to 44.9, and 44.9 is the average amount of neutrons in a bromine atom.